Good evening. And this is question number 2. And here we can see a bead of mass m which can freely move. This is a bead actually. Here we can say this is the bead, and bead is moving freely across this two. The rod is clamped, and we can say the bead is moving freely. And this is the vertical move horizontal rod. This is a rod actually. This is a rod. End of the string connected with one of the string. This is connecting with one of the string. This is a string we can say of mass m connected to a other identical ball of mass m. This is a ball of mass m. Here we can say this is a bead of mass and this is a ball of mass m. Fine. The system is released from the rest as shown in the figure. Calculate the tension in a string just after system is released. Now here we can say once the system got released, so mg force trying to bring back to the mean position, and as soon as once we have released, so there is a some once we release, so what will happen? Tension, now tension start mg trying to bring it back. So once the mg start acting, the so we can say tension has a two component. Tension also act into once the tension start acting to bead, this bead will start dragging in forward direction. So this is the basic mechanism. The bead will move forward direction and this ball will move in the given direction. But earlier what we have seen, if we'll make it fixed, if we will make it fixed, so this mass will execute circular motion. Circular motion. But since it is not fixed, it is moving forward direction. And by what force it will be? So we can say once again tension, it is acting on a bead. Let's say this is theta, this is 90 minus theta. So this horizontal force, it is start acting to make it beat forward direction. So if we have to observe with respect to this beat, to with respect to beat this ball, so we have to take the pseudo force on the ball. By this way, we can make it static and analyze. Fine. So this is the basic observation. Now let's quickly see. Now here we can say the tension force acting on it. Fine. This tension force, I told you tension is acting T sine theta, this tension force. So what is the acceleration t sine theta divided by m. This is the acceleration acting in a forward direction. So t sine theta upon m. This is the acceleration of a bead. So what we can say, this is a bead. So with respect to bead, if you are talking about, we will take a pseudo effect on a ball. So pseudo force acting. So we can say the motion of the ball with respect to bead, it will be executing circular motion as I told you. The initial velocity, of course, it will be zero. Fine. And the centripetal force, now the centripetal force that is acting, since initial velocity is zero, so we can say centripetal force AC is equal to V square by R. Since at initial T is equal to 0, V is 0. If V is 0, so we can say that AC will be 0. AC will be 0 because initial position they have asked. So when the AC will be 0, so we can say that's why centripetal force will be 0. So let's resolve everything. Now here, if we resolve, so this is the B, this is theta. So if you start resolving it, so mg is acting downward, mg, and mg1 component is, this is theta, mg cos theta, and since pseudo force acting, this is a pseudo force that is acting, that is t sine theta divided by m. Fine, t sine theta divided by m, and multiply by a. This is the force m. This is a pseudo force acting, and this is the tension. Fine. So tension, it will going to resolve along. So let's say this is t. So if we will make a equation along a radial direction, so radial direction, it will be t, and once you have taken component of this pseudo force, so this angle would be pi minus theta, pi by 2 minus theta, in fact. Fine, pi by 2 minus v, because this is theta, this is 90, then this is 90 minus theta. So the one component along the given direction, it would be t sine square theta, because sine theta is already there, one component will be t sine square theta. So that's why t minus t sine square theta minus mg cos theta should be equal to 0. And once we arrange, so ultimately we got the relation as t is equal to t cos mg cos theta plus t sine square theta. This is the value. So what we have understood here, we have make first motion, this motion we have make it fixed, pseudo force it is acting, and since they have asking initially means initial velocity, it would be 0 when the initial velocity zero means initial acceleration, that is also zero. So what we have along a radial line, this is a radial line, we have make it equate all the forces, and that is equal to zero. So by this way, we can get the value of tension. So I thought you have understood the discussion. So I have already solved the two questions that I keep on my status. So I'll try my best next day. At least I cover 5 to 10 questions. First in the morning, I will post in the on my status. Please solve, and then I will give you solution gradually till evening. So your mains is in fact advances around the corner. So keep doing practice of these type of question, because these are the few important question that I have taken. So add in your preparation. Till then, take care. Have a nice time.